A very good afternoon to all of you. Welcome back to my channel. This is Shivam Shukla and here I am to solve a problem on engineering mechanics. It's a problem on equilibrium, problem on beams. It's a problem for 8 marks in the university paper. Type 1 problem. To find the support reactions at a hinge support and a roller support of a beam consisting only of uniformly distributed load, that is UDL. It is also known as rectangular loading. Let's see how the question statement goes. Question asked in Mumbai University, May 2013, 8 marks. Find the support reactions at hinge A, here is the hinge A, and roller B, that is the roller support over here B. Now, as you can see, this entire beam, it consists of an extended part over here, but it consists only of a uniformly distributed load having loading intensity as 5 kilonewton per meter. Friends, this is the entire questions diagram. Let us see how the problem will be solved. The same questions diagram as it is drawn over here, and then directly we will be drawing the free body diagram and we will be proceeding ahead with it. Let us first write down what are we supposed to find. Since they have asked us to find the support reactions, so I'll be writing to find over here. So to find is the support reactions, that is nothing but VA question mark vertical reaction at A, HA question mark. Again, apart from this, the reaction, normal reaction at point B, that is RB, is equal to question mark. Now friends, we will be going ahead with the FBD, which is the step number 1 in the problem. As you can see the entire question diagram one by one, what we can do is, first of all, since it's a hinge support which allows only the rotational movement, that means there is a restriction for the there is a restriction created by the support to move the object in horizontal direction and vertical direction. That is why there is a reaction, that is resistance in vertical direction, that is VA, as well as in horizontal direction, that is HA. I can mention it over here, HA. These directions are simply assumed. Same over here, since it's a roller support, it allows rotational motion as well as the motion along the horizontal direction. That is why there will be only one resistance in vertical direction, that will be RB, that is a vertical reaction, vertical normal reaction. Now I will be just showing the loads which are already shown in the diagram, that is 25 kilonewton and 30 kilonewton acting at points C and F respectively. So 25 kilonewton is acting vertically down at point C, so I can show it over here very well. So 25 kilonewton. What about this? So 30 kilonewton over here, 30 kilonewton over here. Then and there I would like to resolve this force, and it makes an angle of 40 degrees like this. So it will be resolved along the horizontal sense. I would like to show it along this particular point, that is its cos component and its vertical component over here, that will be the sine component. So this will be 30 cos of 40 and 30 sine of 40. Friends, you would be thinking why I didn't resolve it over here. Intentionally I have resolved it at point F because it gives me a clear reason. While we take the moment, it will be clear to me where the force is actually acting. So just let me mention the points E, F. This is the point F over here. Now I'll be showing simply the distances. Apart from that, only one uniformly distributed load is left out, which is also known as rectangular loading. Now to convert this into a point load, how do we do it? So it is acting on this entire beam surface. So to convert it into a point load, we apply the formula which is resembling the formula of area of a rectangle. That is why it is also known as rectangular loading. So area of rectangle is length into breadth. So it will be 5 into 4, that is 20, and exactly it will be acting at the center of the span. So I can just show it over here. This will be 20. Of course, since it's a load, point load, that is why it will be in terms of kilonewton. Now I would like to show the distances one by one. Over here, here, this one, this one, here, this distance, as well as this particular distance. All these distances we can show them straight. Okay, so once I draw this line, so I can show these distances straight away. 4 meter, 2 meters. Now since it is acting at the center, friends, so 2 meter over here and 2 meter over here. Okay, this is as it is 1.5 meter, 1.5 meter. Even over here it will be 2 meters. We have drawn this free body diagram, which was the step number 1. Let us go for step number 2, that is the solution of the problem. Now if the FBD is correct, definitely we can go for the correct analysis of the problem. So I'll be going ahead with step 2. I'll mention here step 2, solution. Since there are 3 unknowns, definitely there will be 3 equations that we will be using to solve the problem. Now we will be applying the conditions of equilibrium. Since this particular problem, it forms a general force system, so there will be 3 conditions of equilibrium that will be applicable to solve this problem. So how do we do that now? Applying COE, applying COE, that is conditions of equilibrium. The first condition of equilibrium that we apply, my dear friends, that will be summation of moment about a point at a point is equal to 0, acting in clockwise sense as positive. Why do I consider the moment about point A? Because it was a hinge support and it was consisting of the maximum number of unknowns. That is why if we apply the moment about at point A, we will be getting the value of RB. So let us write down the equation, my dear friends, one by one. So it will be equal to, if I write 20 into 2, this 20 into 2 plus 25 into 4 25 into 4. Apart from that, let us first write this. We'll be writing this later on. Now we need to understand, friends, this 30 kilonewton, as we have resolved it at point F. So now 30 sine 40, actually it will be acting, if I just mark this line, it will be acting at this point by principle of transmissibility of force. So since it's a vertical component, from point A, its perpendicular distance will be this 2 plus 2, 4 plus 2, 6 plus this 2. So that is why it will be 8. So it will be plus 30 sine of 40 into 8. Now 30 cos 40 is acting in anti-clockwise sense with respect to point A. But friends, what is the perpendicular distance? Since it's a horizontal force, if I just extend this particular line till here, over here, just for the explanation sake, I am drawing this. So this particular vertical distance is nothing but 1.5 meter. So that is why, friends, it will be minus 30 cos 40 into 1.5. Last but not the least, now I can write it minus RB, since it is causing the body to rotate in anti-clockwise sense. What will be the distance? 2 plus 2, 4 plus 2, 6 plus 4, 10. Into 10 is equal to 0. Friends, just let us do the calculation of it. It will be easier one by one. 20 into 2 plus 25 into 4 is equal to plus 30 sine of 40 into 8 is equal to minus 30 cos of 40 into 1.5 is equal to whatever the value that we are getting, friends. The whole value has to be divided by 10 straight away. Divided by 10 is equal to, so 25.979. So therefore Friends, I can write it RB is equal to 25 point. I can check the answer again. 979 kilonewton, and of course it is acting in upward sense since the value has come out to be positive. Friends, going ahead with next step, summation of moment we have applied. Let us apply summation fx to get the value of HA. Summation fx is equal to 0, acting towards right as positive. Let us just see the equation diagram and frame the equation. It will be HA minus 30 cos 40 is equal to 0. So therefore HA minus 30 into cos 40 is equal to 0. Therefore HA is equal to 30 cos 40, and if I write this, it will be HA is equal to 30 into cos 40. If I say, it will be 3030 cos of 40, 22.981. 22 value has come out to be positive 0.981 kilonewton, acting towards right hand side. We have assumed it in right, the value came out to be positive, definitely it is correct, friends. Okay, now let us go for the value of VA. Last value which is left out for us is nothing but VA. So summation of Fy is equal to 0, acting in upward sense as positive. Therefore, the equation now that will be termed as VA minus 20 minus 25 minus 30 sin 40 plus RB. So let me write it. VA minus 20 minus 25 minus 30 sin 40 plus RB. Friends, I can directly write the value of RB plus 25.979. So 25.979 is equal to 0. Therefore, VA is equal to, let us do the calculation of it. It will be minus 20 minus 25 minus 30 sin 40. Let me complete the bracket. Don't forget to do it, my dear friends. Plus 25.7979. Okay, is equal to. So value of VA is 1.695. Value of VA is nothing but, just let me check it once again, my dear friends. 20 minus of 20 minus 25 minus 30 sin 40 plus RB. Just let us do the calculation again. Minus of 20, sorry, minus of 2020 minus of 25 minus of 30 sin 40 plus 25.979. So friends, the value came out to be negative over here because we have taken the calculation. If it goes on the RHS of the equal to, it will be plus. So definitely it has come plus. So plus 38 point, let me check again, 0.304, 38.304, 38.304 kilonewton acting in upward sense. Friends, this was the value of VA, this was HA, and here is RB. Just let us write down the marks distribution since this problem is for 8 marks in the university paper. One by one, just let us write down the marks. So this entire FBD, which is the main game changer of this problem, it will be carrying 2 marks. 2 marks along with the equation with this correct value, 2 marks for RB, along with the equation correct value of HA, 2 marks. Last but not the least, along with this, This value carries 2 marks. So here it is, friends. This is how the problem will be solved. Please do like, subscribe and share this channel. Thank you for watching this video. Thank you.